Okay, so now we go through with example 5. And here's what it's saying. The times taken by the competitors at the Rubik's challenge to solve the Rubik's Cube were recorded. The results are illustrated in the histogram. So either way, let's say we haven't quite understood the question or whatever. We don't have to know the question. We don't have to know the information above. But anyway, they say that we have a histogram here. And the question says calculate or construct a frequency table. So all we want to do is to find the frequencies from the histogram, okay? Because the histogram has frequency, density, and the data, which is here, time taken to solve a Rubik's Cube, right? Now, they want us to make the frequency table. So what are we going to do when we're making the frequency table? Well, we first do, remember frequency table is like frequency distribution, right? All right. So what I'm going to do is I'm going to first take the x-axis, which is time taken. So I'm going to say time taken, okay, which is in seconds. And then the other one is I'm going to put the interval width, okay, because I'll have my time taken and I'm going to be able to get my interval width. Okay, we can say first boundaries, and then interval width, okay, interval width, similar to what we've been doing, interval width. And then we now say what we're going to do is we swap. Remember that our table would say, so let me say here boundaries nicely spaced, and then I can then get the interval width. And then after getting the interval width, I'm going to put frequency density first. Okay, we know that our table will start by frequency, then end with frequency density. But I'm going to start by frequency density because that's what we have now. And frequency, what we are looking for, will be the last thing. So there we go. We can say our boundaries. So we go straight down like that. We put another one straight down like that. That straight. And then down, straight. Okay, I'm sorry. Straight down like that. Then straight down like that. Then we can close this off here. And then close this off on the top here. So here my boundaries. Remember that I have two boundaries, which is the lower class boundary and the upper class boundary. There we go. So now we can start putting. What do we have? The time taken. I can see that here. I can call this a 5. And here 15. Then here 30, 25 is important, and 45 because it's in between 40 and 50. I know that. So here, what are my intervals? I have 0 less than or equal to t, which is less than 5 because it's going 0 to 5. And then I have 5 less than or equal to t, which is less than 15. Then I have 15 less than or equal to t, which is less than 20, because I can see here, sorry, let me pull it to black crayon. I can see that from 15 to 20, I have something. So next one would be, I can see that the next one is from 20 to 30. So I'm going to say 20 less than or equal to t, which is less than 30. And then I can see the next one. Oh, it's not from 20 to 30. I'm sorry. It is from 20 all the way to 20 to 35, right? To 35. So it is from 20 all the way to 35. So I can remove less than or equal to 35, right? Because it's going to 35. Okay, keeps going until it gets. Then I have 35 to 45. So I can say 35 less than or equal to t, which is less than 45. And then I have 45 to 50. So 45 less than or equal to t, which is less than 50. Okay, I'm just looking at the width of my charts, my bars. Okay, now what are we going to do? When I have it like this, I can put my boundaries. And here the boundaries are so easy because I have a continuous scale already. Okay, I'm always going to check. Do I have a continuous scale? Here I have one. What do you mean by continuous scale? it's ending at 5 and beginning at 5. Here it's ending at 15 and beginning at 15. So it's continuous. So here, what is 5? What is my lower class boundary? 0, the upper class 5. Here, 5, the upper class 15. Here, 15, the upper class 20. Here, 20, the upper 35. Here, 35, the upper 45. Nothing is changed because it's already continuous. Then here, 45 to 50. Now, interval width, 5 minus 0, 5, 15 minus 5, 10, 20 minus 15, 5, 35 minus 20, 15, 45 minus 35, 10, 50 minus 45, 5. So here, this would be 10, and this would be 5. Now, frequency density, I have the frequency densities here. For the first one, frequency density is, I can see that this would be 4, and that would be 2, 4, 6, 8, 10. Okay, so 2, 4, 6, 8. So it's exactly 4. Yeah, it's exactly on 4. So here it'll be frequency density is exactly on 4. I can see that here. It's exactly on 4 for the first one. For the second one, it's 5.2. Yes, because it'll be 2, 4, 6, 8, 10. So it'll be 5.2. And then the second one would be 7.2.4. 7.4. And then the next one would be exactly 2. Then the next one would be exactly 1. Wow, this is nice. Then the last one would be 0.8. 0.8 for the last one. Huh? You can see here, it says 0.8 if you follow that. Okay. Now we can be able to get our frequency. What do we use? We know the formula says frequency density is equal to how much? Okay, because it's a density. And density is how much over the space. So it's frequency over the width. Now to get frequency, we take width to the other side. We say frequency density times the width is equal to the frequency. So that means I'll be just multiplying the interval width times frequency density. I'll get frequency. So what is my interval width? 5 times frequency density 4. What will be my frequency? 20. 10 times 5.2 would be 52. 5 times 7.4